In this video, we're going to talk about combination. The word combination is different in counting problems from the English meaning we say in real life. And in this case, combination is a special case of multiplication rule and using a multiplication rule. And compared to permutation, the difference is we know when we learn the permutation, the order matters. No repetition, and the order matters. No repetition means you cannot use some object or some person twice. And the order matters, which means if you switch two people or two numbers or two letters, then you'll get a different permutation. But in permutation, still we don't allow repetition. There is a way to do the problems if you allow permutation, but right now we talk about no repetition. And in this case, order does not matter, which means when you switch two numbers or two letters, two people, it's not going to change. It's the same combination. For example, let's say we have 5 people, A, B, C, D, E, and you want to choose 3 people to work on Christmas Day or Christmas Eve. And well, the way when you choose A, B, C, or you could do A, C, B, or B, A, C, B, C, A, or you can call C, A, B, C, B, A. Previously, these are considered as 6 different permutations. But for combination, these 6 different ways are considered as the same thing, because it doesn't matter whose name you write down first. You could write down A, B, C, or A, C, B. That's the same 3 people that will work on Christmas Eve. And so that's no difference when you are selecting people to do something. The way when you change them, it's gonna be the same 3 people. So in this case, the order does not matter. But we know that if you scheduling shifts like morning, afternoon, evening, that will matter, because B works in the afternoon, C works in the evening, will be different from C works from in the afternoon, B works in the evening. But if we don't doing shifts, we just say all 3 of them have to work the whole day throughout the day. So when you call ABC to work on the next day, and it will be the same as you are calling ACB to work the next day. So the same 3 people will show up to work. The same for all the other ways. So the biggest difference between combination and permutation is in combination, the order does not matter. That's why I'm saying it's a little different from in real life. In real life, when you say you have a safe box, you choose a combination, and of course, when you choose ABC or CBA, that would be a different combination. But over here, in counting problem, this word combination has a special meaning, and the order does not matter. Sorry, I should put does not matter here. But if I choose get rid of C, I replace C with the D, I do A, B, D, that would be a different combination, because one of the person is different. So instead of having ABC working next day, I have ABD working the next day. One of the person is different. That's considered as a different scheduling or different combination. And similarly, I can replace C with the E. So I get ABE. Again, that's a different way. And then and we can get rid of A to replace A with D. So we have B, C, D. And we could have and I listed all the other different combinations here. So later on, we don't really want to list every single one. We want to find a formula that can tell us how many combinations we have without listing every single one. So what I did is pretty much we just fix AB first and try to replace the third person with a different person. So I have ABD and I have ABE. And then I'm going to fix AC, get rid of B. So I have ACD, ACE. And then I fix AD with ADE. And then we're going to get rid of A and fix the first two persons as BC and BCD, BCE. And then we do BDE and CDE. So together, if we count, we have 10 total different combinations. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, the way I'm doing this right now, so we can figure out how to get that formula. And notice that for combinations, we only have these 10 different ways. So let me just mark here. We have altogether 10 combinations. But we want to find a relation between combinations and permutations, because that's how we found the formula. And we know that in combination, the order does not matter. So that's why all these 6 different ways here. So we have 6 different ways, permutations for each one. So for the top row, the top rows are different combinations we have, including this one here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But for each combination, there will be 6 different permutations. So for example, I can similarly do for ABD, if I do different combination permutations fixing ABD. So we have ADB, switching the last two, and then we put a B at first, BAD, and the BDA. Then we put D first, DAB, DBA. As you can see, we have 6 different ways. Similarly, for each of the different combination, you can always do another 6, another 6. So I'm not going to write down all the other ways. And so for each of these, you're going to have 6 different ways, 6 different permutations. But so again, notice a total we have we should have 6 different ways, different permutations. But because each combination repeats 6 times, so we take 60 divided by 6, that will give us 10 combinations. So the idea is, first of all, let's see how we got 60. Well, right now I'm just counting them because each row has 10 and we have 6 rows, so that's why how I got 60 here. But we can actually use a formula to do that, because we learned the permutation formulas before. If you look at all these different ways listed and assume the more order matters, this is really like we have 5 elements and we want to pick 3 of them to do a permutation. So that's exactly P53. And we know to do P53, that is equal to the 2 formulas we learned. Let me move it down here so we can see better. So to do P53, we can either do 5 times 4 times 3, and 5 minus 3 is 2, 2 plus 1 is, so you can stop right here. That gives us 60. Or if you don't remember when to stop, and you can use the other way. The other way to do it is the top is 5 factorial. The bottom is 5 minus 3 factorial. This formula is easy to remember. So you're going to get 5 times 4 times 3 times 2 times 1. On the top, on the bottom, we get 2 factorial, which is 2 times 1. After you cancel them out, you get 5 times 4 times 3, which is 60. So without listing every single permutation, we should have a total of, so including all of these, So all of these are, what are these? These are P53, which is 3 permutation of 5 elements. So the top number, this, can be obtained by doing P53. Let's see how we get the bottom number 6. And notice we choose it's a 3 combination, so we only choose 3 people. Every combination here, 3 numbers. And to rearrange these 3 numbers, that's like a 3 permutation. So P33, or you can just, so we have three. Once you select ABC, you have three letters. To rearrange them, that's exactly a 3 permutation. So it's like do a 3 permutation of 3 elements. And a P33, we can do the same thing. It's 3 times 2 times 1. P33, you go all the way down to 1. So that gives you a total of 6 different permutations. So the bottom is P32, 33, sorry, P33. So that would be the formula for a combination, how to get 10. So let's write down the formula from this example. So if I want to find this combination of 5 and choose 3, see 5 choose 3. So that's the symbol. It's very similar to permutation symbol. We just change the first letter P to C. And we can see the formula is P53 divided by P33. So that's the formula. So in general, if I have C and choose R, following the pattern here, the top is pretty much the same except you change C to P. So you're gonna, instead of doing permutation, a combination, first we do permutation, P and R. But because some of them, not necessarily 6. In this case example, we have 6. Every 6 of them, these 6 different permutations can only be counted once. So that's why we have to divide by 6 on the bottom. And so in this case, we're going to divide following the pattern. So we take the smaller number and do a permutation, P, R, R. So this will be the formula for combination. And we can simplify this a little bit. First of all, looking at this formula, why do we have this? So remember, permutation in order matters. Changing the order will give you a different permutation. But in combination, order doesn't matter. Changing the order will give you the same combination. To get a different combination, you have to replace change one of the letters. At least one of them is different. So that's why first, when we do combination, we assume we're doing permutation. We found all the different permutations, a total of 60 of them, corresponding to the top P and R right here. And then we have to find out how many times does each combination repeats. So every 6 of, so like these, it depends on how many you choose. So if we choose 3 of them, so that's P33. It's a 3 permutation. 3 times 2 times 1, because every 3 letters there are 6 different ways to rearrange the order. And so that's why we take the smaller number. If you have R people and how many ways to rearrange them, that's PRR. So that's the idea of doing combination, why we get this formula. So the next thing we want to do is to simplify this formula a little bit. So let's put it over here. So C and choose R is equal to the top P and choose R. And we know P and choose R, the permutation formula is n factorial divided by the difference of these 2 factorial. So the top will give us n factorial divided by n minus r factorial. And the bottom is PRR, and we know PRR is just r factorial. So that goes on the bottom. Now we use a little bit of algebra. The top divided by the bottom. Means, so let me rewrite this symbol divide as using the traditional division symbol by r factorial. And using the property of fractions, we use keep, change, flip. So divide fractions are like multiplying the reciprocal of the second one. So then we multiply straight across. n factorial times 1 goes on the top. The bottom we have n minus r factorial times r factorial. So the final formula we got for combination is this. So C and choose R is equal to n factorial divided by n minus r factorial times r factorial. So that's the final formula. There is another way to calculate this, because you can actually, so there are also 2 formulas similar to permutations, which we will discuss later.